Properties of exponents, product properties. Before we start, there's a couple of things that I want to go over and that are very important for this lesson. And those two things are the 3 and this tiny 4. This 3 is known as the base and this tiny 4 is the exponent. What you probably didn't know is that together this is referred to as the power. Okay, so the power, this expression, is not saying, oh, 3 times 4. The answer is 12, miss. Nope, that's not what it's saying. What it's saying is 3 must be multiplied to itself 4 times. So what I just did is I expanded the expression so I can really understand what is happening. So this is 3 times 3 times 3 times 3, and the answer is 81. This is known as the simplified answer to this expression, to that power. Okay, so we're going to apply this idea to variables because, you know, it's algebra, and that's what we do. We apply things to variables. Example, it says, simplify the following expression by expansion. So I'm going to expand n cubed times n to the 4th. That means 3 n's and 4 n's. In total, we can say there's 7 of them. So the simplified answer would be n to the 7. And that's it. Now you might be wondering, okay, I think I see a pattern. This 7, did it come from these two numbers by doing something to them that can give me a 7? Well, before you assume, let's try another problem and let's see if that really does work. We're going to go ahead and simplify this problem here, but first we need to expand. So all this is saying is 2 with times y 3 times 7 times y. So everything is multiplying. And this is where we're going to use two properties of multiplication that say, hey, you can use a commutative property. What the commutative property does is it allows you to rewrite what you have in a way that is more pleasing to your eye, as in, it's better to have the 2 and the 7 right next to each other, so rewrite them right next to each other. And then it's better to have all your variables next to each other, so go ahead and do that. That is a commutative. You can move these around. Again, but in multiplication. Then comes the associative property. Associative property means now that you move them around, group them. Put them in groups. That way you can simplify. So I'm going to perform the operation between those two, which is multiplication. So 2 times 7 is 14. And then we have y multiplied 4 different times, and that is y to the 4th. That is my simplified answer. Now again, you might be thinking, okay, I definitely see a pattern here. This 4 for the y, did it come from this 3 of the y and this y? Together, if I add them, it gives me a 4. The answer is yes, and that brings us to our first property, the product of powers. To multiply two powers that have the same base, write the base and you add their exponents. So when we have b to the m, this power, multiplied by this power, they do have the same base. It is multiplying, therefore I can use this rule. So instead of expanding like we just did in the previous examples, we can simply do the shortcut and apply this property, which is add the powers. So let's try it. We're going to go ahead and apply it. Okay, so the first thing I'm going to do is I'm going to rewrite all this mess without parentheses, and I'm going to demonstrate how everything is multiplying, because that's what this all means. Parentheses means to multiply. All these variables with the numbers are multiplying themselves. Next, I'm going to use the commutative property. Again, the commutative property means rewrite what you have in a way that is more pleasing to your eye. So what I did is I rewrote this where I have my p's together and my t's together. Now, how did I determine, okay, p goes first and then the t, or does the t go first? It doesn't matter, but usually it's alphabetically in alphabetical order. So the p's first and then the t's. Then I'm going to use a commutative property, associative property, which says group the things that are alike, the things that are the same. Okay. This way we can simplify. So 3. This is multiplication, and if you notice, they have the same base. So we just learned a property that says add their exponents. So I'm going to go ahead and add the exponents for p. And the same thing for t. Same base, therefore, add the exponents. Now we can truly simplify our answer and say that 3 to the 4th and t to the 5th is the simplified version of this problem that we were given. Now, if you're not sure, if you get confused, you can always expand it, but you'll see that this is a final answer that you get. Let's try this again. Different problem. Again, the first thing to do is rewrite it without so many parentheses. Okay. Now, there's a reason why I left parentheses around the -4 and the -6, and that reason is we don't want to confuse this with a -4 or a -6, because that's not what's happening. Those are actually negative numbers. So we're going to apply the commutative property, which says rewrite it in a way that is more pleasing to your eye. So I'm going to put my coefficients first, and then alphabetically I'm going to arrange the variables in this way. Okay, so associative property says group the things that are alike. They belong in a group. So I'm going to do that. I'm going to group all this. The reason we're doing this is to help us understand that now we can apply properties. So for example here, -4 times -6 is just +24. Here, well, this r has a power of 1, and it's multiplying r to the 5th, and I just learned a property that says that I can add their exponents. Same thing for my t's. This t has a power of 1, so that is 3 plus 1, and same thing for the x's. I can add them. Now I can truly write my answer in simplified form by adding the exponents. And this is our simplified answer. Okay, simplify the following expression again. We're going to expand. I'm going to expand this in 2 different ways. The first thing I'm going to do is look inside what's in the parentheses. C cubed. C cubed means C written or multiplied 3 different times. But there is an exponent of 2 outside of that parentheses. So we need to rewrite it because it means something. What this means is that we need to copy this that many times, twice. So I'm going to copy it twice. And finally, without needing the parentheses, I have 6 C's in total. So instead of writing C times C times C times C, I can just say, oh, my answer is C to the 6. Okay. There's another way of expanding this. I'm going to rewrite what's inside of the parentheses that many times, twice. So C cubed times C cubed. Inside each parentheses, I have C cubed, and that means C times C times C, C times C times C. Well, without so many parentheses, I have 6 C's multiplying each other. So really, this is just C to the 6. Now, you might be thinking, couldn't I have gotten that 6 by somehow using those two numbers, those two exponents? Well, the answer is yes. And that brings us to the next one, the power of a power. To raise the power to another power, you're going to write the base and multiply the exponents. So for example, let's say we have this power raised to this power. Oop, wrong one. This power. What it says to do is keep the base and simply multiply the two exponents. And that is exactly what we're going to do without expanding so much. So let's apply the rule. What we're going to do first is we're going to separate these two things because there's two different variables, but both of these variables are inside of the parentheses. So we're going to go ahead and apply the rule by first separating them. So power of a power says that we need to multiply the exponents. When we have a power raised to another power, this h has a power of 1 times 6. And now we can simplify. We can say g to the 24th and h to the 6th is the simplified answer. Okay, not bad. Let's try a different example. Here we have three different things inside of this parentheses. Everything is raised to the power of 4. So I'm going to do exactly that. Every single thing is going to be raised to the power of 4. So I'm splitting everything up. I'm going to apply the property now. And it says to multiply. So 2 right now has an exponent of 1. So that is 2 to the 1 times 4. W to the 3 times 4. X to the 5 times 4. So I'm going to rewrite this a little neater. This is 2 to the 4th, W to the 12th, and X to the 20th. But before you say, okay, that's it, I'm done, we got to look at this carefully. 2 to the 4th, we can actually figure that out. We can actually simplify that and get an answer of 16. These variables, however, nothing much we can do, so they remain the same. Therefore, this is our simplified answer. Simple. Okay. Next property, zero exponent. So the zero exponent property says that any base, any number that you can think of, except 0, raised to the 0 power will always be equal to 1. So let's say in our calculator, we wanted to try 15 to the power of 0, 173 to the power of 0, anything to the power of 0. Oop, and I made a mistake here. This will always result in the answer of 1. So we're going to apply that. Simplify the following expressions using the 0 power and other properties. So, h to the power of 0. Nothing we can do there. The answer is 1. Simple. By definition, anything to the 0 power is just 1. Exactly what I said. Anything to the 0 power is just 1. But we got to prove it. So we're going to apply the property that we just learned, the power of a power. So here we have g to the 9th raised to the 0. So the rule says multiply them. So if I multiply both powers, I get a 0. Now I can say, okay, my answer is definitely 1. Next one. Anything to the power of 0 will result in the answer of 1. But we need to check if this is true by expanding, well, not expanding, by applying the previous rules. So I'm going to separate everything first And then I'm going to apply the rule that says multiply the exponents, power of a power. Here we get 7 to the 0, f to the 0, g to the 0. Well, we just learned that this is 1, this is 1, and this is 1. Well, what is 1 times 1 times 1? 1. So yeah, the answer is 1. And at the end, last problem. So here we have 3 times c to the 0 times e to the 5th. Okay. 3 stays the same. C to the 0, we just learned that anything to the 0 power is 1. E to the 5th stays the same. Commutative property says move things around, which we don't have to. Associative property says group the things that are the same. So by doing so, 3 and 1 are together and they're multiplying. So 3 times 1 is 3. Bring down e to the 5th, and this is our simplified answer. Okay. I hope this video helps you.